Dear students, I am Mrs. Pratibha. So again I have come with us to teach you mathematics. So the topic which I am going to teach you today is the factorization. So under factorization chapter, we are going to learn about these things, that is how to factorize the algebraic expressions and how to factorize by taking the common factors and factorize by grouping. These are the three concepts that we study in today's session. So you all know how to find the factors of a number. Yes. So if I say write all the factors of 8, you will say 2, 4, 8. So similarly, if you take an algebraic expression, for that algebraic expression also we have the term factors also. For the algebraic expression also we can find the factors and then you can write you can factorize it. So let us see what is that factorizing. So first one is factorizing by taking common term out. So first concept is taking the common term out. So now, before line the common term, so we'll identify the common factors of the given algebraic expression. So if a monomial is given, if two monomials are given, so let us find what are the common factors. So we'll start from the beginning. We'll start studying the factorization from the monomial terms. So if two monomials are given, how to identify the common factors. So here, so the first question is find the common factors of xy and x square y. Okay. So common factors of xy and x square y we have to find out here. So how to find the common factors? Now factors of xy, so solution. So how to find? So factors of xy are, what are the factors here? X and y. If you are getting confused, if I take 16 can be written as 8 into 2. So what are the factors of 16 in this? 8 factor is, first factor is 8, second factor is 2. So these are the factors. The same way, here x into y, so x is a factor. Now the factors of x square y will be x because there are 2 times 2x is multiplied equals x comma y. So what is there for the common factor? So we have to find the common factors. So what are the common factors of x, y and x square y? So what are the common factors of x, y and x square y? Now how to identify? Now we've got the common factors here. So you got the factors of x, y, you got the factors of x square y. So we will see. Now here you have x. So here you have x, right? You have here 1x and here also you have 1x. Do we have one more x here? No. The x is common here. What about this y? Yes, here there is y and here also there is y. So which are the common factors of x and y? X, y and x square y is x, y. So common factors of x, y and x square y is x, y. So this is how you find the common factors. So we write r x into y. So that is the common factor between x, y and x square y. Let us do one more problem. So let us see. So 5x cubed y square and minus 4x square y square. Yes. So again, let us do from the beginning. So how to do it? So solution. So next first we will find the common factors of 5x cubed y square. So we will find the common factors of 5x cubed y square. So what are the common factors of the 5x cubed? 5 is the factor, x is a factor, x is a factor, x is multiplied 3 times, and y comma y. Next we will find the common factors of which term? Minus 4x square y square. So I'll take this as minus 4. One of the factor, x and y and y. This y is multiplied twice, y square. Now we have to identify the common factors. So therefore, these are not the common factors. These are the factors of 5x cube y square and factors of minus 4x square y square. Now we have to find the common factors. Common factors of, so the factors of 5x cube. So common factors of 5x cube y square and minus 4x square y square. So we are finding the common factor. Previously, now here what we have found is the factors of 5x cube y square and factors of minus 4x square y square. So what we have to do here? Yes. So again, identify which are the common factor. Do we have 5? We have 5 over here. Do we have 5 in the next one? No, so that cannot be. Here there is x. So here also we have 1x. Here there is x. So do we have x here? Yes, we have x over here also. Here there is 1x. Do we have x here? No. So I cannot circle that. Don't have a common thing. Next, here there is a y. Do we have y here? Yes. Monomial also we have y. Here also we have y. Here also we have y. So what is the common factors for x cube y square and minus 4x square y square? It is x this x into this x into this y and this y. So we are writing this common factor. So what is this? X square and y square. So these are the common factors of 5x cube y square and minus 4x square y square. So this is how we find the common factors. So now look at these common factors. So instead of doing all these things and writing each and every time, what I said, there is a simple method techniques to find x square y as the common factor. What you have to do is, you have to see both the algebraic expressions given. So in that you have to check which are the common variables. So here we have x, here also we have x. Done? Yes. So we have the x as a variable. So that means we have x as a variable. Now, you have to check in these two algebraic expression which variable x has the lowest power, which is that x square is the variable with the least power. So that becomes your common factor, one of the common factor. Next, which is the other variable? Do you have any other variable that is common, which is present in both the algebraic expressions? Yes, which is that y. Yes, both the algebraic expressions we have y as a common variable. Both the algebraic expressions we have y. Now again you check what is the least, which algebraic expression has the least of power. So in this variable, two variable, what is the least power of that variable? Smallest least power of that variable. So which is that least power? Y square. So that y square is your common factor. So can you from that and from the simplification, did we get the same variable? Yes, so we got the same common factor. So this is how we can do. How can we do it? We have to check two algebra expression. If we have to compare two algebra expression, take those two algebra expression. Find out, do we have any common variables in that. So here we found that x was common here and here. So x was the common variable. Now in that, those variable which has the least power, that should be taken as a common factor. So here x was a common variable. So what was the least power for that? It was x square. Here we had x cube and x square. So least power is x square. So that is written as one of the common factor. Next, again we have y also as a common factor here, variable. Common variable in both the algebra expressions. So which in that y, which has the least degree? What is the least degree of that variable? You have to identify the least degree of the variable. Least degree of the variable is y square. So that becomes one more common factor. This is how, without doing these simplification, directly we can find the factors. We will do one more example. So see. So 3 I will take 27 m cube n cube, comma minus 8 m square n cube, and 75 m cube n square. Solution. So how to do it now? So therefore the common factors of, I will do it directly. Common factors of 27 m cube n cube, comma minus 18 m square n cube, comma 75 m cube n square. So will be equal to the right answer here. So how to find out now? So now we can see that 27 minus 18, 75. These are the numbers. You can see this comes in 3's table, this is there in 3's table, this also divided by 3. Yes. Now how to do it? Which are the common factor between 27 minus 18 and 75? So how to find out? So highest common factor. So common factor between 27 minus 18, 75. You have to find the HCF, highest common factor here. So what will be the highest common factor here? So this can be written as 9 into 3. 18 can be written as 9 into 2. This can be written as 3 into 320. Yes, 320 5s are. So 3 into 25. So this again 3, yes, 3, this 9 can be written as 3 into 3. This can be written as 3 into 6, right? So everywhere we have 3 as a common factor. So this is how we can find the numbers common factors of a number. Otherwise what you have to do is you have to do the HCF, highest common factor. HCF you have method, you have to do long division, or you can do prime factorization, that also can be done. So here you can see that 3 is the common factor in a numerical values. Now we have to go for the variables. Now variable, let us check. Here we have m, here also we have m, here also we have m. Yes. So one of this is m. Correct? Now here what is the least power of that variable m? Here it is m cube, m square, m cube. So least power is m square. So that is the common factor. Next, which is the other variable which is found in all the 3 algebra expressions, n. So in all the 3 algebra expressions we have n. So what is the least power or degree of that variable n? That is n square. So it is n square. So we can say that. So here the common factors are 27 m cube n cube minus 18 m square n cube, 75 m cube n square is 3 m square n square. So this is how, without writing the common factor of this separately, we can find out the common factors of a given algebraic expressions. So this is how we can do the, yes, so this is how you can do it by long prime factorization method also, or you can do, so this prime factorization method, 27 minus 18, so 75, minus can get excluded here, and then you can do 3, 3 9s are, then 3, 6 are, 3 25s are, so we don't have common factors, so HCF is 3. So highest common factor is 3. This is how we can do the other method. So here 9, 6, 25. We don't have anything which is divided commonly by any of the factor. It cannot be divided by the same factor. Even commonly divided by any of them, not divided by any of the factor. So directly we can write HCF is 3. So this is one method. We have to find the highest common factors of the given numbers. So this is how we simplify, find the common factors of an algebraic expressions. So using these method, that is after identifying the common factors, we can by grouping also we can factorize the algebraic expressions, and also by taking the common factors out also we can factorize the algebraic expressions. So we will study about the other two concepts in the next sessions. And thank you.